Right, this is another video I'm going to do, and what I'm going to call this video is about it's really to do with software development, and I'll explain. Basically, I've got my Galaxian board, which I use as a test board, with the emulator plugged in, as you can see, and the red light's flashing indicating that it's watchdogging, but the emulator will still run anyway. That's one thing it can do, because it doesn't use the reset off the board. Anyway, to cut a long story short, the other day I found some ROMs in my junk box which were of an old operating system that I wrote many years ago, and I used to use this on Z80 based computers that I built at the time. So I thought it would be a good idea to try and resurrect these ROMs and try and get them to work on a Galaxian board, because a Galaxian is a Z80 based system. So after a bit of fiddling around, etc., I created a bin file based on the ROMs, and you can see I've got it booting up. Excuse me. So you can see, if I zoom in now because I've got a better camera, it's called ZEOS 3-1G, which is Z80 Extended Operating System 3.1 it used to be called, but I've added a G because it's Galaxian. I've changed the code a little bit so as it will work on the VRAM instead of the original video display memory that it used to have. Underneath it should tell you how many bytes are in memory free, but it doesn't really do that at the moment. It's got OK, and it's got a little cursor at the bottom. And all seems to be fine. I can do a reset on it and you'll see it will boot all the time. And that's as far as it's really got. It's an ongoing thing. I'm just having a go at this every now and again. There is an issue with it, mind you, because if I turn the power off, and the emulator is obviously powered down, and I turn the power back on, you'll see there's a little problem here. It comes back up, which is Hello again, this is another video I'm going to do, and this video is all about software development on the tester. The tester does have a facility now, when you use it with the add-on, which is the emulator, you can then develop your own Z80 code, modify, etc. And I'm going to show you a little bit of how to do that. What I've got here is my Galaxian board, which is a test board. I just use it as a test board. It's a working Galaxian board, bootleg, and I've got my emulator plugged in, as you can see at the moment, and it's powered up, and it's running a little program which I found in my junk box a while ago. Some ROMs I dug out, which were for an operating system that I wrote many years ago, probably almost 30 years ago to be honest with you, when I used to build Z80 computers. And I thought it would be a good idea to try and make this thing work on a Galaxian board, being it's a Z80 again. So after a little bit of jiggery pokery, I managed to get it to work with the VRAM on a Galaxian board. Instead of the original 80 characters by 16 lines, it's now working on a Galaxian screen, which is obviously much smaller and obviously around the other way. And you can see there on the screen I've got it booting up, and if I zoom in, because my camera lets me do that a little bit better now, you can see it says ZEOS 3-1G, and then it's got a lot of stuff underneath it. Now the ZEOS, I called it that originally, which stands for Z80 Extended Operating System, and it was originally 3.1. I've changed it to 3-1 because obviously the Galaxian ROM doesn't seem to have a dot in it, I've noticed. So anyway, and I've added a G because it's Galaxian. Underneath it says a load of garbled stuff, bytes, which means it should actually tell you how much memory you've got left. That doesn't work at the moment. And it's got OK, and it's got a little cursor underneath it which is a dash. And all's fine, it's running that. Now that's as far as it's really got. This is an ongoing thing. I just pick it up and have a go at it every now and again. But there's a little problem with this. You know, if I just do reset, it'll reset, as you can see, all the time. But if I turn the power off, now the emulator will keep the program because it's got a battery on it, so it's battery back to the emulator, and turn it back on, you'll see it'll come back up, but it's all shifted, there's colours, all sorts of things. The reason being for that is the colour RAM on the Galaxian board is not getting initialised. So the colour RAM is getting just random data in it, which shifts each line left or right by a certain amount and adds colour to each line. So what I want to do is I want to add a little bit of code to this operating system bin file that I've created, which basically initializes the colour RAM when you boot it up. Now I have actually worked out a little bit of code already, which is here, and this is what I'm going to type in. Now I found an area of the bin file which has nothing in it, which I can put my code into. So I'm going to make a little subroutine called clear RAM, and it will start at 1035, and it simply just loads up the address, which is 5800 for the color RAM, and I load in 0400 bytes of character 0 into all the locations, which basically initializes the RAM. It sets the shift values to 0, the color values back to 0, etc. So we're going to put that into it, and then we also have to change where it starts, because at address 0 it originally goes to jump or JP029A, but what we want to do is we want to put a call in there before that to call this little routine to clear the RAM first. But if we put a call in, we're also going to have to change it so we've got a stack pointer set up as well, otherwise it will not return to the same point. And I'm going to set the stack pointer to 43FF, which is the top of the Galaxian RAM, so it's well away from anything else. So I'm going to show you how we can add this code into the tester and run it. So the first thing I'm going to do is I'm going to set the camera up. My desk is a mess, but we'll set the camera up and hopefully zoom in. Which I think should be okay there. If it focuses on that, it'll be fine. There we go. Hopefully that's alright. Okay, so what we're going to do first of all is, the important thing is to stop the emulator because it's currently running. I'm going to use it in easy mode, which means you can type in stop, run, etc. So we'll just type stop, and the emulator will now be stopped. Now we want to add our code in to address 1035. So we type the address 1035, all hex of course, set the address up, and just to check there's nothing there, I'm going to look at the memory and it all comes back as zeros. So that shows me that I've got a space there that I can do something with. We'll just put that back to 0. Right address to make sure we start at the same point. We'll clear it so we get a fresh screen. Okay, so the first thing we need to do is give this subroutine a name. Now, to type anything in, we have to use the input mode of the tester, and the input mode of the tester is signified by doing a little arrow like that. Every line starts with a little arrow like that, it will take as an input, and it will process it accordingly. So, to set a variable or a label up, we put a hash, and then we just type the label name, which is clear RAM, enter, and you'll see it will set the address at 1035 and it will call it clear RAM. So that is the start of our little subroutine. And now it's a simple matter of just typing in the code. So we'll just type in the Z80 code basically as it appears. All numbers have to be prefixed by an ampersand as well. That is quite important, otherwise it will not accept that and you'll get a syntax error. So 5800 is the start of the colour RAM, so we're going to load HL registers with that. Now we'll just type in the next line, which is load BC, comma, again, ampersand 0400, and that's going to be our counter. BC will be the counter, and we're going to do it 0400 times, which will fill the whole RAM up. 0400 is 1k in decimal, by the way, so it's a 1k RAM that we're going to load. Now the next thing is we need somewhere we're going to loop. We're going to loop round, so we want a point to loop back to. So we'll loop back to this point here. So again, we need to set another label up, and we're going to call this clear RAM loop, surprisingly enough, and that point is now 103B, and we're going to use that as the point that we're going to loop back until it's finished filling the memory. And we can continue now to type in our Z80 code. Again, ampersand 00, we're going to load HL, so the address in HL will be loaded with the value 00, which will clear it. We then go to the next address, which is inc HL, and then we'll also decrement the counter by 1, which is dec BC. Now we need to check if the counter's got the 0. So the first thing we'll do with this is we'll load the accumulator with B, because BC is the counter, and then we're going to OR it with C, which will give us a value, and if B and C are both 0, we will get a 0 back. But if it's obviously not 0, then it means the counter is still going. So the next stage we'll have to do is to jump back to the loop point if it's not 0. So we're going to do a JR, which is a jump relative. Now NZ, because it's not 0, we want to jump if it's not 0, comma, and we're going to put the label in. But when you put a label in, you have to include it in brackets. So we're going to say clear RAM loop, which is the loop point, remember, in brackets. This is very important. Any labels have to be put in brackets like that for it to work. And what it will do now is it will do a syntax check on that, and it will also work out the relative jump value to do that, which it has done. F8 is the value it's come back with, so that will allow that to jump back to that point previously. The last thing to do in a subroutine once we're finished is basically return. So we return out the subroutine, and that's that. Now the other thing we need to do is we need to change the boot address, because we have a little problem there. We need to call this routine now. So we'll set the address to 0, and I'm going to disassemble 8 bytes. So just type dis 0008 and it will return the code. You can see it does at the moment just jump to 029A, but what we want to do is put in that little bit of code. So we're going to set it back to 0, and again, remember this is going into the emulator RAM. We're going to load the stack pointer first of all, which is load SP, and we're going to say 43FF, which will set the stack up. And then we're going to call our new routine. So we're going to say call space. Again, we're going to use the label, so we have to put the brackets clear RAM, and that's it. So we'll now call clear RAM, and then finally we will send it to where it wanted to go in the first place, which is JP, again ampersand, it's a number, 029A, and that's it, put it back. So now we've put our little subroutine in, and we've changed it so it will call that before it goes off and does the rest of it. So the first thing we'll do is we'll just type run, start the emulator back up, and reset. And if I get my camera back, we'll see if it does anything. At the moment, it's just the same as before. And I'm going to type reset, which I've just done, press enter, and it's booted up. So we'll try that again. No problem. Now the problem was when we turned the power off and turned it back on, so we'll see if it does it this time. So the emulator is currently running. We're going to turn the power off. You can see the lights have all gone off. Now we're going to turn the power back on, and it's booted back up. We'll do it again. Booted back up, and it's clearing the memory as well before it does it. So you can see that's solved that little problem. Now what I want to do is I want to do something a little bit different. I want to change the colour of the cursor. Now the cursor is on the last line of the screen, so what we need to do is load in an address with a value, because the first 64 bytes of the colour RAM set the shift value and the colour data for each line of the Galaxian screen, known as 32 lines or columns. So if we pick the last one and load a value into it, we can change the colour of the last line, which is where the cursor will be. So what we're going to do is we'll go back to the screen and we'll add that in. So let's see if that works. Let's see if we can get this zoomed in again. Looks a bit squint, but it'll do. Okay, first things first, stop the emulator. Okay, now we need to go to where we typed our little subroutine. We're going to put something at the end of our little subroutine. So if we do 1035, which is where we put our subroutine, and let's disassemble that again. So we'll go dis 0020, it'll bring back our code. There you go, so 1035 clear RAM, and that's what we've just typed in. Okay, so the return which sends it back is at 1043 in hex. So what we're going to do is we can continue, we'll write over the return and continue with a little bit of extra code to change the colour. So let's change that to 1043. Okay, and now we're going to put an extra bit of code in. So we do input mode, and we're going to say load A, comma, ampersand because it's a number, 07, which will be the value we're going to set for the colour. Let's load that in. Now we're going to load an address. Now I've already worked this out at 583F. So we're going to say load brackets ampersand 583F in the brackets, comma, and we're going to put whatever's in the accumulator or the A register into that address. There we go, and now we can type return again. So all we've done is added 2 lines in, which will load in 07 into 583F, and then we'll see if that has an effect. So let's get the camera back and we'll see what happens. Obviously that's it as it was left off. Now I'm going to type run, and then we'll type reset to give it a good start. And I don't know if the camera's picking this up okay, but you can see the cursor has turned purple. So we now have white text with a purple cursor. So that works fine. Turn it on and off to make sure it doesn't cause any problems. There you go, so it's booting up every time, so that's another little thing. Now I'm going to stop the emulator again. You can see down here I've got both lights on. I've got the tri-state light on, which indicates the emulator is disabled, and this flashing light indicates that the board is watchdogging. That is the reset line of the board, and it indicates it's watchdogging. It doesn't matter, the emulator doesn't need the reset line of the board because it has its own line. So when you see that light flashing and the code's running, you know the board is watchdogging. Now the final thing I want to do with this is I want to save it. So we'll set the address, whoops, I'm holding the camera this time so it's maybe not as stable. We'll set the address to 0, and I know that the code fits into 8K of memory, so which is 2000 hex, and I've already called it Zeos Galaxian 1. So what we'll do is we'll set the address to 0, very important, and we'll just type save. Saving that, and what it's doing is it's overwriting the bin file called Zeos Galaxian 1 with a new version, and it's taking it out of the memory of the emulator. So once it's done that, then the program is then saved. So if we load it back in, all our changes will be there. And it saved it. And that is how you modify or write Z80 code on the tester. You can't do it on a standard tester. All testers will do it, but you do need the emulator board, which this is the prototype one, the new ones are getting built. The emulator board will allow you to do all this because it will have the RAM on it. If you don't have that, then you can't do it. The only way you can do it is you can salvage some memory out of your Galaxian board and write your program in that, but you won't be able to run it because the Z80 will always run at address 0. So that's it. So that's a little video showing you how to write and modify Z80 code on the tester. Thanks for watching.